the last lecture of this module on walls and masonry, we shall look into some of the defects and issues related to durability of brick masonry and walls in general. Therefore, outline of our lecture today would be defects in walls. First, we will look into some of the defects in walls, and these defects include dampness, cracks, spalling, surface disintegration and other defects, and then some defects in external finishing. So, that is what we will look into. Right. So, let us look into what are the kind of possible defects. In fact, defects in walls can be caused by, they can be actually classified into three types of varieties, right. All the defects broadly one can classify. Of course, there is no sharp line of demarcation, still one can possibly classify them into causes can be classified, they could be caused by three possible things. Now, first one and the most common is the dampness leading to moisture marks. Normally, that is what one would observe. Dampness is a very common defects or problems, durability related problems in masonry walls and masonry structures in general. In buildings in general, that is very common, and then that lead to certain additional things, like it is this moisture ingress that can lead to deterioration of concrete. We have seen that reinforcement, corrosion and so on, which require moisture ingress. So, therefore, in buildings dampness is a major problem. We will try to devote some of our time to this issue. Then of course, cracks. Now, cracks is essentially related to forces. So, you applied forces leading to cracks, some sort of forces, forgetting about special cases like heavy wind, very high wind effect, or use wind loading, or exceptionally high sudden let us say earthquake or seismic loading. Even otherwise cracks can come, and we are looking at those issues, not of those high loading or accidentally high loading. This we are not looking, but normally cracks can come into structures, masonry walls and masonry structures, and we are looking into those. And then some dimensional changes that actually sometimes leads to crack, or sometimes some other kind of defect, local cracks and things like that, spalling of brick and so on so forth. So, some of this we will look into. So, that is how we will look into actually, right. So, first let us look into dampness. So, dampness is walls is presence of excessive amount of water leading to appearance of damp patches, that is what is dampness. So, what is it actually? Dampness means there will be excess water, then that should be, after all water is always present there. In fact, in most of the cementitious material we know, because there will be chemically combined water, and the water is a part of the system itself, absorbed water. Some amount of water can be absorbed water as well, or mechanically held, but that may not give rise to dampness. We may not feel like any discomfort or aesthetically poor look it may not give. So, when this moisture content becomes excess and it gives us an appearance that there is a presence of damp patch there, that is what we would call as dampness. Otherwise, presence of moisture per se may not be dampness all the time, because after all chemically combined waters are always there in many of the cementitious materials. In bricks also absorbed water could be there a little bit, but it may not be a problem in terms of dampness. Dampness means that you must have an appearance of damp patches as well, and this can be caused through water ingress from rain penetration. This is one major cause. Sometimes rain penetration from the rain, and then it can be due to leakages from pipes leakages, excess water coming in from there. Then it can be due to ingress of moisture from ground through capillary suction. This is very important, because you see, ground contains water, groundwater is always present, and we know most of these masonry materials, they are capillary porous, their absorption is much higher. The amount of absorption can be 10-12%, and of course, the maximum amount is fixed in the code. 24-hour standard absorption is fixed, and we have seen that absorption is of the property which is important as far as brick is concerned. But brick generally, normal bricks, ordinary bricks, they would be capillary porous and they would allow moisture to come in through them through capillary action, and there can be rise of dampness, rising dampness could be present there due to capillarity from groundwater. So, this is one situation. And then this situation, the last situation that we are talking of, condensation, is not very common in India. Usually it occurs in such places where there are cold climate, outside climate is cold. In fact, it would look something like this, because we will not discuss much about it. So, let us just discuss right away something about it, let us discuss something about it right away. It can be something like this, like you have the wall, right, and outside is cold. This is outside and it is cold, outside is cold, outside is cold. So, cold, actually condition is cold. This side is warm, this side is warm condition. So, this surface is cold. So, when humid air, air containing moisture vapor, humid air travels towards this direction and touches the cold surface, Now, the humid air means there is some amount of moisture vapor present in the air, and capacity of air to hold on to the moisture, that is a function of the temperature itself. So, we talk in terms of relative humidity. Relative humidity is nothing, but it is the ratio of the amount of moisture present in the air divided by the saturation moisture content at that particular temperature, expressed in kg per kg weight of mass of dry air. Moisture content in air is expressed in terms of kg per kg mass of dry air. So, that is relative humidity. So, when you have relative humidity, so the amount of saturation moisture content is a function of temperature, and as the temperature reduces, the amount of water the air can hold, or the saturation moisture content becomes less. So, when suddenly it comes in contact with a cold surface or somewhere in between, let us say if I have a cavity wall or something, somewhere in between also within the wall, somewhere it comes in contact with the cold surface or cold, it becomes cold, its saturation moisture content reduces, thereby its relative humidity will increase. So, RH will become relative humidity increases. So, as relative humidity increases, it may so happen that it reaches the saturation moisture content and still the temperature is lower. That means, the moisture present in the air is more than the amount of moisture the air can hold at that particular temperature. What will happen at that stage? Condensation. The excess moisture will condense out. This can happen within a solid wall, and then there is a problem, then you can see moisture patches. It can happen within a solid wall and you can see moisture patches. If it happens within a cavity wall, of course, cavity wall has that advantage, because in the cavity wall it can be drained through the cavity out. It can happen in surface also in some cases, as we shall see. So, condensation is that kind of a phenomena. Whereby actually it occurs mostly when inside condition is warm and outside condition is relatively cold. So, warm air coming in contact with somewhere, its temperature is getting reduced, and the dew point, as we say, that means the saturation, its moisture content becomes saturation moisture content, the dew point has been reached. Now, below this temperature, if the temperature is reduced further, the amount of moisture present in the air will be more than the saturation moisture content, and then therefore it will condense. So, condensation is that kind of phenomenon, and it can lead to dampness in buildings, especially in cold countries where it is maintained warm. But this can also occur in some part of the northern part, J&K, Himachal Pradesh, etc. of India as well. Right. So, this is the fourth issue, fourth type of reason why dampness can occur. Right. Now, let us see causes for groundwater, dampness in basement wall. Let us see dampness in basement wall, right, dampness in basement wall. Okay. This can occur when groundwater is under pressure, very high groundwater pressure. If it is there, then basement, you must be aware of what is a basement. A basement would be like this is your ground level, let us say, and you have construction here, right. So, this is the basement level. Now, here basement wall is there, basement wall is there, basement wall is there. Now, you can have dampness here, you can have dampness, you can have dampness here, dampness can be here, can be observed here. This can happen if there is excess pressure, the water pressure, water head here is excess pressure of the groundwater is there, then this might result in pushing through the permeable wall. This even happens sometime in concrete wall as well. Usually basement walls should be RCC, and it happens through those also, not necessarily masonry, but happens through concrete as well. And water, if this is this, so this can show signs of dampness here. Now, if such dampness signs are being shown, or even high amount of water is coming down, it will depend upon what is the function of the basement, what are you doing in the basement. If you can tolerate some amount of water in the basement, then you can create a sump, and from there you can pump it out, right, you can pump it out. Otherwise, you can even construct drains here, such that with such kind of filtering system, so that water percolates into the drain, provides slope, and it is drained out. It could be one of the reasons. The other thing could be make this system impervious as possible, make this system impervious as possible by various kinds of means, like putting injection or chemicals inside which will block the pores, because it can only come through if it is permeable. If there is a permeation possible through this, then only it can come. So, you actually densify this or reduce down its permeability. Sometime you can give treatment here. So, these are the kind of remedial measures that would be available, but there is no one remedial measures, it would depend upon case to case. Right. So, dam penetration through permeable construction, that is what happens, and injection grouting or rendering inside. Rendering is nothing but some kind of a plaster, thick plaster, but that is not a very best solution. The rendering, although it has been mentioned, it is not a very best solution, because you provide a rendering to the inner surface, you are providing rendering to the inner surface like here, but moisture, that means will penetrate up to this, moisture will penetrate up to this portion straight away, which means that it will attack. If air is also present, unless, and it is unlikely to be saturated all the time, it will be only saturated for some period of time, but after that it will be partially saturated, and even it can be dried up unless there is continuous moisture supply from outside, which normally would not be the case, because groundwater level would rise only during possibly the rainy season, then it will go down. So, there is a situation of wetting drying possible, which means that it would be wet, saturated for certain period of time and dry for certain period of time. So, if that is the situation, then what will happen? All the deterioration process in a reinforced concrete structure, if it is reinforced concrete, then this can take place. So, in a reinforced concrete situation, providing rendering here may not be a very good solution, because it can attack all those internal reinforcement and so on. So, internal rendering could be the other solutions, and condensation in the basement wall is possible when it is cold. If it is warm inside and cold outside, then condensation. That is what we have explained. What is condensation? We have just explained. So, it can happen that way, right. So, dampness in basement wall we have looked into. Let us look into dampness near ground. Now, if you see dampness near ground, this can be caused by no DPC. Now, to avoid, we said that bricks are capillary porous. So, what you do, or rather I will show it in a diagram, bricks are capillary porous. To ensure that the groundwater or capillary rise do not take place through the brick wall, we provide damp proof course at the plinth level. That means just above any soil level, just above any soil level. So, whatever, and usually it has been bituminous treatment. There can be varieties of chemical treatments today possible. Earlier it was all bituminous treatment, waterproofing treatment, which will not allow capillary water to rise through, and that is called a damp proof course, and it is provided all through the wall. It is provided all through the wall, right, through the cross section, through the whole periphery, through all the walls in the building. So, just above the plinth level, as we shall see now. Now, first thing, so rising dampness is possible, or near the ground it could be due to rising dampness. Now, if such a thing is happening, that could be one thing, could be that there is no DPC. So, if there is no DPC, well, or DPC is there, it has failed, or there could be situation bypassing of the DPC. We will see the bypassing of the DPC, but there can be failure of the DPC. DPC has got damaged, it is now working pretty old and it is not working. So, in such both these situations, what you can do? You can actually try to provide the kind of a waterproofing course. Now, such thing can be done through chemical injection, not very best method, but this can be done through chemical injections, various chemical injections such that you create an effectively impervious layer within the brick level of the DPC at the level of the damp proof course. Right. So, chemical injections of the kind which will be usually in liquid form, high viscous liquid form, which when like when enters inside solidifies in the long run, because either the solvent evaporates or the chemical reaction or curing takes place, by which the liquid which is entered, that actually solidifies. Usually the second type is likely to be there most often. So, it is solidified, it has to solidify, it injected as a liquid form, enters into the brick and then it solidifies. There are various kind of construction chemicals in this connections, and chemical injection techniques can be used. Well, if the bypassing of DPC takes place, just as an example, this is the example of bypassing of DPC. You see, this can happen. This example shows how bypassing of DPC can take place, right, how bypassing of DPC can take place. For example, this is your damp proof course, this is the level of your damp proof course, right, and this is your flow level all over. So, through the wall, this is the flow level, this is the flow level throughout, and you can see, you see this is your damp proof course. So, this is just below the plinth level you provide, so that soil is here. So, no soil, from soil nothing can enter inside, just above the any soil level, no soil level should be there. Now, supposing what you have done, one would have possibly heaped up soil around. This could be one situation, there could be many reasons similar bypassing the DPC. So, the DPC should not be bypassed. Now, if supposing a heap of soil has been put here like this case, then the moisture will enter through this, and this moisture will then travel by capillary rise, and you are going to see wet patches here, right. So, if there is some board or something, if there is some board, skirting board is there, that might be affected, it is a timber one, it might be affected due to this, and even through the plinth moisture will penetrate. So, this is what is bypassing of the DPC. Now, what is the solution to such situation? If bypassing of DPC is taking place, then remove this soil. People what they do, sometimes they create possibly plantation, they do small gardens and outside the building, and this situations are quite often observed. So, when this has happened, that original plinth level, much above the original plinth level, we have put in some soil, and that soil absorbs moisture, this can go. So, what you got to do, you just simply remove this portion, ensure that no soil is there above DPC level. There can be several other situations also in cavity walls and so on, that similar skirting of DPC may takes place, right, or bypassing of the DPC may take place. Rain penetration. So, we have seen some cases like groundwater, capillary rise situation, which I mentioned. Out of the 4 things, condensation I have discussed a little bit. In fact, I have started the reverse order. First I discussed the condensation, basement also related to condensation, then we discussed about capillary rise situation. Now, let us look at the rain penetration. If it is, what does rain penetration do? You will find damp wall with signs of efflorescence after after the rain, if the rain penetration is taking place. We remember efflorescence, we will of course discuss about efflorescence again today a little bit, because it is a kind of, it may of course not a major durability problem. Efflorescence is nothing, the soluble salts, because moisture enters into the wall, the moisture evaporates from the surface, up to the surface it brings in the salts, but the moisture itself will evaporate, right, liquid water will become vapor and then it will evaporate, leaving the salts at the surface. So, you get patches, white patches, so marks of patches, and this must be quite common in many places in walls. Most of you might have even observed in many places, because this is an unusual phenomena. So, damp walls with signs of efflorescence, and usually inside walls in patches, that is what you will see, and normally they will appear just after the rain, 1 to 48 hours after rain. In fact, you will see that this occurs after dampness should be observed more after the rain. it is also a way to actually diagnose what is the cause. For example, you can see the periodicity of appearance of the dampness. If it is there all the time, then the moisture source is there also all the time. If it is there only for certain period of time, then it dries off, leaving its marks. Then it means that during that the period the moisture was, it was in the source, moisture source was there. So rain, if it is rain penetration, then you will see just it after the moisture marks or wet situation, you would see mostly after the rainfall, or 1 to 48 hours rain it will appear. And then this could be because of inadequate thickness and leakage or overflow from the rainwater drain pipes, the gutters. So inadequate thickness could be one of the reasons. Now IS SP20 I said, or IS code 1905, it deals with a little bit of rain penetration, and SP20 is the commentary on that particular code. It gives you some guidelines in tabular form. So inadequate thickness is the issue what has been dealt in, and what are the condition where you should have what kind of thickness, that has been suggested in the code. We will look into that just now. So thickness, the basic principle is very simple. I have mentioned to you earlier sometime that the principle is something like this. This principle is something like this. You have the wall, right? You have the wall, let us say, you have the wall, right, or the section, and rainwater will come through this, right. Rainwater first of course hits here. Usually when rain falls vertically, there is also a wind velocity, and there is a terminology called driving rain index, and that index is nothing but the product of the rainfall intensity in millimeter multiplied by the wind velocity. It is something like that. Velocity is an index, velocity multiplied by the rainfall intensity. Now, so usually there is a horizontal component of the velocity. Because of the velocity, there will be horizontal thrust. So there will be some horizontal flux of the water at this surface. Now this will result in what? Moisture content profile. If I draw it, supposing I draw the moisture control profile, you will have high moisture content here, moisture front if I may call it, it will go on entering like this. After some time, moisture front will enter further, and then it will enter further. Now the idea is that if the rainfall continues for long period of time, moisture front will advance within the wall from the exposed side to the unexposed side. But rain does not continue for very long period in any place. Okay, at best it may continue for its intensity, maximum intensity obviously will get reduced down, say it continues for few hours. Now in this process what will happen? Moisture front will advance, but after that rain stops. So when the rain stops, drying starts from here. Now thickness should be sufficient such that by the time the moisture rain stops, the moisture front should not advance to the inner surface. I think I have mentioned it earlier, I am repeating it again. The thickness should be sufficiently large such that, okay, we can look into more details of the same thing. Thickness should be sufficiently large, this thickness should be sufficiently large, this thickness should be sufficiently large, thickness should be sufficiently large, thickness of the wall should be sufficiently large such that the wet front, if this is the moisture front, this is the moisture content, what I am saying, this is the moisture content value, and this is the thickness, x axis is the thickness, moisture content value, here the moisture content is 0. So after some period it has increased like this, then further the rain continues, maybe it will be something like this, maybe it is saturated here, maybe it will not increase here, but it will increase here. So saturated, it has become saturated, but the moisture front should not reach at this point. Thickness should be sufficiently large such that the moisture front does not reach here. That is one of the way of protecting against one of the ways of protecting against the rain penetration. So inadequate thickness, if it is there, there can be rain penetration, but quite often it is something else is happening. Either the rain water is accumulating onto the rooftop, the gutter is blocked, or it is there is some kind of overflow that is taking place, or somewhere there is a leakage from the rainwater, and that is how the rain water penetration can take place. Now the code gives you this sort of a table, resistance towards rain penetration. The table has got, as you can see, particulars of the wall particulars, then it gives you different types of walls. Say burnt clay and lime brick, or oblique, let us say burnt clay or sand lime bricks masonry, 1 brick thick wall, let us say unplastered. Then it recommends, if it is only 1 brick thick wall, it is only 1 brick thick wall. If it is sheltered, there is no rainfall, then it is recommended, R stands for recommended. If it is moderate or severe, it is not recommended, because thickness is not sufficient. I do not have even a plaster here, simply 1 brick thick wall. So, it should be only partition wall or within the building, that is what it is. Similarly, same brick, clay brick plastered on both sides if you have, and you have 1.5 inch, 1.5 thick brick, then it is recommended everywhere. It is recommended everywhere. 1 brick thick means something like 225 millimeter or so, and no plaster, then it is in very severe rain condition, it is not. But if it is 1.5 brick thick and you have plaster on the both sides, then this is sufficient, thickness is sufficient, and it is recommended even in most severe rainfall condition. Similarly, there are many others in the code table, you can look into the code table, but I am just trying to give you the whole idea and the basis of it. Concrete block masonry 20 centimeter, concrete block masonry, let us say 20 centimeter without any plaster on any side, then it is recommended here sheltered, but not recommended and not recommended in moderate or severe rainfall. That means, if you are using it northeast, either of these cases is not really recommended in northeast, where the rainfall is very high intensity, or driving rain index would be also very high sometime. Okay, same as above, but you have plastered on both sides, then it is recommended throughout. So, code gives you more details about the same, but we are not really right now interested in the details, total details. We are just trying to look into what the, so one can look back into the code, refer back into the code and look into it. Right. Remedy against driving rain, they can be rendering, increase the thickness, rendering means plastering, increase the thickness. So, we put a kind of render on the external surface, this will give you. You can give some sort of application of some surface treatments. I will just discuss this surface treatments, application of certain types of surface treatments we can give, and this surface treatments are, there is include one of them, it includes the rendering as well, but you can have certain coating, but they would be costly. So, you have to use it judiciously, possibly if it is just rain penetration, you need not use anything, because it is costly situation. So, the cost has to be seen, but all the types of surface treatment possible both on masonry and concrete, I am just going to give you. You can provide an additional outer leaf. What I mean by additional outer leaf is that you have already the wall, right, this is your wall, already existing wall, you provide an outer leaf, but this would serve also good purpose for condensation in cold climate, but here of course is, and this is of course sort of, or even it should be, it can be just rendering or outer portion of the wall, you can increase that. So, that could be one of the solutions. Let us see the surface treatments. So, these are the kind of in concrete, if it is concrete, of course, one can use water repellent admixtures. I mentioned to it waterproofing compounds, even in mortar you can use those, that is what I mentioned, but this admixtures which go, they are mineral and vegetable oils of calcium stearate, and that reduces the absorption. I mentioned to you earlier also in connection with the concrete, and they can be added to the plaster, or in concrete surface if it is there, then in the additives you can use. But the surface treatments which are there are 4 types of surface treatments which can be used on masonry, but even used in concrete. Some of them are costly, and one has to see in masonry, therefore, they are used very judiciously, not just like that, because the cost is an important issue. Like coating is one of the ways, you just provide a coating, because all this mortar, concrete or brick masonry, they are all porous. So, these are your pores, let us say these are your pores. So, if you put a coating, very fine coating, it will depend upon the situation. Fine coating can be 600 or 300 micron thick epoxy coating, which will be costly, but you have to see coating could be one of the solutions. But remember, coating will not allow anything to come out, no moisture vapor can come out through it. So, coating could be one of the situations. There is something called hydrophobic lining. Now, this lining, what does it do? They go, and this is a silicone, for example, silicone treatment, silicone silicone treatment, various kind of silicone compounds are there. Details of course not part of our discussion at the moment, but let me introduce this. What it does, you know, water is a wetting liquid. Water is a wetting liquid. It is something like this. Water is a wetting liquid. You know, water is a wetting liquid. It would just, you drop water, it will spread all over the place, because its contact angle with most of the solid is considered to be 0. If you have mercury on the other hand, mercury, then it will just form sort of a, you know, it will not spread, it is not wetting, because its contact angle, this is the contact angle, is more than 90 degree. Contact angle with the solid is more than 90 degree. So, therefore, if you want to force mercury into such pores, you need pressure, whereas water goes on its own by capillary suction. Silicone treatment or surface lining treatment are those ones. What they do is they change the surface characteristics. They go into this ones, you know, they get the lining, as you can say, in the pores, and they actually change the surface characteristics. Like wax, for example, if you put wax onto this surface, you know, if you put wax onto this surface, like you put wax treatment, then you put water, it is not going to spread. So, that is what this treatment does. It is a liquid actually which will penetrate into and then forms a, changes the surface characteristics in such a manner that the what is called contact angle changes, and therefore, water cannot penetrate, but vapor can of course come out through it. So, that is what is one of another kind of surface treatment. Two other kind of surface treatments are pore blocking treatment, but that is usually for concrete, not for in or mortars, but not in bricks. These ones go into the concrete system and reacts with calcium hydroxide in case of or mortar cementitious system, and that will block the pores there. So, it will block, this is called pore blockers, right. This is called pore blockers. There are several sort of crystalline pore blocking treatments available. Again, details we will not discuss, and this is more towards concrete rather than brick masonry. Mortars of course same thing, but these two systems are relatively costly. Rendering is that I was mentioning all the time. This is nothing but a thick layer. You put a mortar layer, you can put all varieties of kind of mortar layers today, polymer modified mortar or ordinary mortar, cement concrete, cement sand mortar, one can put rendering, and this will also not provide resistance against rain penetration. So, this surface treatment can be, and possibly in case of brick masonry, putting this is the most cheapest way. How do I diagnose the dampness problem? Damp wall with blistered or discolored finish near the ground level or permanent. What is it? Rising dampness would give rise to damp wall with blistered or discolored finish near ground level usually, and they are permanent. They do not go away unless you have removed the soil or wherever it is coming from, right. So, that is rising dampness. Lack of DPC, I said, bypassing of DPC or DPC material failure. So, this rising dampness can be diagnosed in this manner, right. Rain penetration, I have already mentioned that it is 48 hours, 1 to 48 hours after the rain it will come. If it is leakages from the pipe, that also you can find out, because it would also depend upon usage of the leakage pipes. Supposing it is a wastewater pipe, right, wastewater pipe, and then some people who occupied it, they left this place for some period of time. You will see that it has dried off. Whenever these pipes are being used, then you will find the wetting is there. When the pipes are not in use, so you can stop use of this pipe for temporarily to see whether the dampness really prevails. If it does, then that means it is coming from this. I mean, it is not from the pipes. So, but normally one would also, because the proximity to the pipe also has to be there. It is a little bit of judgmental and experience and a little bit of trial and error to arrive at what is the cause of the dampness. Now, if it is leakage from the pipe, you will find damp area, and then mold and algal growth will also take place. Some efflorescence always you will see. This mold and algal growth you see with all kind of dampness. Inner surface in patches you will see, and permanent in nature generally, because pipes are used most of the time. Corroded pipes or faulty joints, these are the two reasons why pipes leakages take place. So, you have remedies, simply remove the pipe, rectify the pipe. If it is joints, rectify the joints. If it is corroded pipe, replace them. there is no other solutions, but diagnosis is very important. I said 4 causes, main type of causes are there. If you can diagnose the cause, then solving is not a problem. Quite often what is done is, when it is faulty joint pipes, the major reason you will find that even if you have relayed your pipe, it still might be leaking, because the joints have been faulty. If one has to do the testing also, new pipes once laid, they should be tested as per the IS recommendation under full pressure or whatever it is, or smoke test if it is waste pipe and so on. So, whatever is the Indian standard recommendation also, although this is not part of our discussion, but testing has to be done, because this lead to quite often the dampness in walls and other places, and dampness has got a cascading effect in RCC or structural element. So, if you do not attend it, it may increase your cost of repair or rectification in the long run. So, that is very important, one has to be alert about this. How do you investigate dampness? Visual observation, then look at nature of damage, location, time, because I said you have to see that pattern, and sometime instrumental survey is also possible, because there are moisture meters, several other techniques could be there, but then we are not going to discuss this at the moment. So, that is what it is about the dampness. Next let us look into the cracks in walls. Cracks in wall can be of 4 types. Toothed, we will see what is the tooth cracks, and remember, cracks mostly come from some sort of load, some sort of force application. Load, I mean, when it be load, some sort of force application. Vertical and straight, diagonal, and then horizontal cracks. We will try to discuss, there may be several reasons and there are varieties, many things involved in this actually, but we will try to just look into how the cracks look like and one possible cases in each of them. Now, this diagram will tell you all the types of cracks, right. For example, when I said toothed, this is a tooth crack. This will look like this. Usually the cracks in brick masonry comes through the joints, because that is the weakest link, we have told you earlier, and therefore you will find the cracks come like this, cracks comes like this. This is a tooth crack, this is a tooth crack. It is getting separated, along this direction, A vertical crack can also come, but such vertical cracks even pass through the brick also. Such vertical cracks, tooth or vertical, these are vertical cracks, this is tooth, and this is straight, vertical straight crack. So, it has also passed through the brick as well, some cases it can happen. Horizontal cracks usually through the mortar joints, and then diagonal cracks will pass like steps. So, these are the types of cracks normally visible in brick masonry walls, and let us see what can cause some examples. There can be several causes, and it would depend upon, it would need diagnosis, looking at the situations, and there can be several causes, types, things resulting in several causes resulting. I have just taken 1 or 2 cases. For example, for vertical cases, sort of heaving or swelling of the clay under center of the building, this can result in crack formation like this, this can result in crack formation like this, this can result in crack formation of this form. You see wide crack here, less. What is happening? It is separating out. There is a force, vertical force like this, which is causing it to separate out in this direction and separate out in this direction, right, separate out in this 2 direction. So, you have wider width of the crack here, lesser width here, and this will be through and through breaking the bricks as well, vertical cracks. So, just as an example of vertical cracks. Now, why does this happen? Possibly you had a clay material which was dry, and possibly the moisture came in and swelled off. It became, the moisture variation in the clay could have resulted in this, right. So, swelling of the clay has taken place, and this has resulted in this formation. This is an example of a vertical crack. Let us see some other diagonal cracks in wall, and this can also, again, the example that I have taken is also from the soil, from the forces due to the soil. Now, supposing the trees they were there, they would maintain the moisture, it was cut. So, this tree which were actually they have felled, so trees have been felled. Now, this were holding on to the moisture, this will dry off then. Once it is felled, it will dry off. Next time, if the drying can result in shrinkages, So, force due to, then when moisture comes in, then it is only one side, not below, not at the center, but at the corner there can be heaving force if actually moisture comes in later on. So, when this becomes this dried clay, the moisture comes in, it starts heaving, and when it is heaving, trying to push it this side, it will result in sort of diagonal crack, which it is actually trying to rotate about this point, it is trying to rotate about this point. So, this is a force here acting like this, and this will result in diagonal cracks of this form. This is one example. There can be several reasons, usually they are related to foundation or soil related matter usually, but there can be other causes which lead to diagonal as well as vertical cracks. Now, let us look at horizontal cracks, and before that just looks into what kind of deterioration process goes on bricks. We have talked about this efflorescence quite a bit, but and we have also said that it is not a major cause of concern from long term deterioration point of view, but sometimes salt crystallization may have a little bit of problem. Efflorescence gives you a look, aesthetic look problem, but the more major problem is sulphate in the clay brick may react with the mortar, resulting in expansive forces leading to cracking at various levels. This is one of the causes which can lead to various kind of cracking, horizontal cracking at several sort of situation, even in the finishing. Then long term thermal and hygral cycle may also result in cracking. Thermal expansion, differential thermal expansion on the window top sometimes results in horizontal cracking. These two causes can result in horizontal cracking. Now, I have taken example of this, it is a real life example. Just above the window level, at the lintel level, at the level of the window, the differential expansion and contraction due to thermal can result in horizontal cracking. But I have taken the example of this, and let us see that example. This is a real life situation. You can see in many cases in old buildings, parapet wall, along the parapet there is a crack. Now, this is usually due to sulphate. What happens? The sulphate present, if it is present in brick, quite often they are present in soluble form, and they come out over the long period of time and react with the mortar, cement, tricalcium aluminate in the cementitious portion of the mortar, cement portion of the mortar, and then this results in a trangite formation, which you know. So, when such a trangite formation is taking place, it may along the mortar line of the mortar, for example, this is your brick, let us say, this is your brick, and over this you have, let us say, is the mortar joint, over this is, let us say, is the mortar, right. Now, this mortar sulphate comes in here and this expands. So, if this is expanding, anything on top or free side would actually, there will be a upward pressure exerted by this, there will be upward pressure exerted by this, any expansion here would exert upward pressure. And in case of parapet wall, at its base what happens is there is a separation created, because sulphate attacking the mortar causes expansion, and this expansion pushes up this particular one upward, and a crack results. So, this is one example. There can be several other possible cases, but one has to diagnose accordingly. Okay, we will look into some of the defects in external finishing, This is very common. Shrinkage of rich cement plaster results in random cracks. Now, these cracks would look like this, these cracks would look something like this. If this is your wall, you will find cracks are in, there is no single pattern or something, they are in all direction, random cracks formation, right. They can be of all kinds. So, such kind of shrinkage cracks in the cement plaster, especially the rich one, 1:3, very rich, and the curing has not been done properly. So, this results in shrinkage, and shrinkage cracks, they do not have any pattern. Now, one of the ways of avoiding this, of course, these days you have got various kind of fibers, say polyester or polypropylene fibers, which you can add to the mortar, and they can reduce down your cracks. But cheaper way would be, this also is a solution, all right, but one has to see, preferably do not use a very rich plaster, it should not be very rich. And second issue is the curing part of it. The curing has to be undertaken and thorough curing has to be done. So, that is what it is, and it is continued for the appropriate period of time. So, if that is done, normally these cracks will not appear, right, normally these cracks will not appear. Okay. So, usually for rich cement plaster, and the remedial measure is obviously related to this. In plaster, predominantly horizontal cracks after certain period of time could be result of sulphate action. In such case, what one has to do is look into the sulphate content, soluble sulphate content in bricks. That means, you find out subject possibly the brick to water for a long period of time, distilled water or something, find out the try the solution out, test the solution out, is there sulphate present in that. Such sulphate when present can come in contact with the cement of the plaster, and then or even onto the mortar, it might act to the mortar joints between the brick, and when mortar joint is trying to expand, it will actually result in horizontal cracks. Generally their patterns are something like this, this you will find, if this is your walls, you will find everywhere, many places you will find horizontal cracks. But all horizontal cracks need not be because of this reason. This is one of the examples of horizontal cracks can be there. One has to diagnose in detail looking at it, and might case by case basis one may have to diagnose, but this could be one of the causes. Right, this is called lime. There is something called lime blow. Lime blow result in plaster, and something called lime blow. Okay, that I think I am coming later on, but there is something underburnt bricks can result in spalling of plaster because of presence of salt, and usually in frost action. Sometimes this is not, this of course spalling, spalling of plaster is not a very common thing in Indian situation, but it can happen because of the sulphate action. I will come to that sometime later on, but frost action can result in presence of salts if they are there, and if they are expansive in nature within the brick pores, let us say they form and they are expansive in nature, that can cause spalling of the plaster. Spalling of the plaster will occur when there is some expansive forces within the brick itself. So, when moisture comes in, some salts crystallize, some sort of salt crystallization takes place. This can be also happening because of the sulphate present in the brickwork. In the long run, first it will form cracks, then it can cause such expansion that it actually spalls off. Frost action can do that because the frost also causes expansion. So, complete plaster can spall off because of this sort of situation when there is expansive forces within the brick. Right. This is interesting situation. Spalling of brickwork. This can occur if it is in a framed structure. This is your RCC, let us say RCC frame. This is your RCC frame, and you have this occurs usually in infilled walls. And you have brick masonry wall here. Right. So, this is your brick masonry wall, this is your brick masonry wall, right, brick masonry wall inside, and such situation spalling of concrete can occur when there is shrinkage of, there is excessive shrinkage and creep of these ones. So, in the long run, long term shrinkage and creep may result in sometimes spalling, because this is shrinking, which in other words it means it will actually exert a kind of compressive forces onto the brickwork, and this compressive forces, if the brick is not strong enough to resist, or brickwork is not strong enough to resist these compressive forces, spalling can be observed from this portion of the brickwork. Right. So, this can be one of the reasons why this spalling of brickwork could take. Surface disintegration usually results from frost action of exposed brickwork. When I have exposed brickwork, again not very common in Indian situation, but when I have exposed brickwork, something like this, the bricks are exposed brickworks, then what can happen is, this is your exposed brickwork, because the frost can, this is the mortar portion, this portion is a mortar portion is here, So, this is the brick face, and moisture can penetrate inside this, moisture can penetrate inside this, and during the cold season, if this freezes, so that will cause expansive forces here, and this will result in actually disintegration of the bricks. So, after some time what you are going to see is, you are going to see it, this was the original situation, and after some time what you would see is this. So, this portion of the brick, some portion of the brick from outside, they will be actually spalling off. Some portion of the brick from outside actually, in the mortar, some portion of brick and mortar, you might find that this just simply disintegrates and comes out in flakes, So, that could be due to frost action, but again this is not very common in Indian situation, right. Lime blows is the other one that I was talking about. What is lime blows? You see, if you have fossil in the clay in brick making, right, fossils in the clay in brick making, bones and things like that, which actually while burning, I mean they do not get grinded. If you are grinding the clay, of course they can be grind into lime. There is essentially some sort of unsoundness associated with the lime, free lime sort of situation. So, what will happen if you have fossils in the clay, this clay when you try to mix in the mixing, grind it somewhat, it does not get fully grinded, but if this is there in the system in some sort of powdered form and they have used it in the molding, then what will happen? They have become lump of lime, calcium oxide, remain as lump of lime within the brick, right. And in future when moisture comes in contact, there will be expansion, there will be heaving forces, there will be expansion, because calcium, it will become slacked lime, it will tend to become something like that, it will absorb moisture and expand in volume. And when this does, that is called lime blow, and that would cause disintegration of the brick itself, right. Okay. So, therefore, some of the defects we have been able to cover in this discussion, cracks and other kind of defects. Dampness, first we have discussed dampness, and we have tried to look into what are the possible causes of dampness. Of course, these defects we have classified in these terms, dampness, cracks and other defects in masonry, and we looked into dampness, we have tried to classify them, classify the dampness in terms of causes that gives rise to dampness. Say rainwater could be one of the causes, capillary rise could be the other, and then condensation could be the other one, and leakage of pipes. And then we try to see say rising dampness, what could be the diagnosis of such problem if it is available, and how first to investigate or look into it. Let us say where they are likely to find them mostly, we will mostly find them near the ground, as we have seen, and they can occur because of the some sort of either the DPC is not there, DPC is not working, it has failed, or it is being bypassed. That is what we have seen in case of rising dampness. Then we have seen the other rain penetration, and we have also looked in the cordal provision to avoid rain penetration. And then we have seen condensation, we have also tried to understand what is condensation, how it causes dampness, and also looked into leakage of pipe and rain penetration situations. Right. Then we looked into cracks, but remember these cracks, as we have seen, they are not exhaustive. We just looked into a few of them. We said that there can be vertical cracks due to soil heaving at the bottom. There can be diagonal cracks. If the soil pressure which causes foundation heaving takes place at one of the corners of the building, then it will result in diagonal cracking. But diagonal crack can also come if somewhere settlement of the foundation is taking place. Instead of the heaving on one side, if there is a settlement on the other side and nothing happens on this side, then can be diagonal crack formation. And then the horizontal cracks, which are mostly results of we said that sulphate or similar attacks, right, crystal formation and expansion taking place at the mortar joint, resulting in sort of vertical pressure which separates out at the horizontal mortar joints. And then we have looked into also the finishing, defects in finishing which can result in cracking quite often. They can be due to shrinkage and surface treatment, rainwater penetration treatment also we have looked into. So, and other defects that we have mentioned. So, I think with this actually we finish our discussion on masonry and walls. in general in this module. So, walls and masonry, although mostly we have covered masonry and we are thrust was mostly to brick masonry. But one point I would like to mention here, which we will discuss sometime later on, is that we have also our discussion focused mostly on brick masonry, and clay bricks are the most commonly used one. Sometime we will look into this at the end of our discussion. One of those last discussion is a sustainable construction. Now, concrete and clay, they consume a lot of energy, very high embodied energy content they provide into the building. Steel of course is a highly energy intensive material, but then the amount of steel used in building is relatively small. But concrete and clay brick, they have a lot of energy content in them. So, energy already embodied energy in there. So, from sustainability point of view, clay brick is not a very good proposition, which I have mentioned earlier, and we shall see this issue later on. So, I think with this we can finish off our discussion on brick masonry and the module 6, and next we will look into the module 10 and discussion on bricks we can conclude, and next we will look into the other material and other construction. Thank you.